In the previous videos, I demonstrated a floating bar mechanisms to hold the tool heads. The floating bar is equipped with two carriages at its two ends. These carriages feature curves in the shape of the T-nuts, which allow for a slight angle to align the XY gantry. However, is a larger curvature better for this purpose? Hi, welcome to Slow Engineering. I'm David. The carriages are designed to achieve several objectives. They need to guide the bar's linear motions on the z-axis and allow for a slight rotation in the y-axis based on the printer coordinate. The floating bar also needs to be fixed in other directions and rotations. For the z-axis motion, the longer length of the carriage provides more excellent stability for the bar. The carriage length ensures fixed movements in the x and y directions. However, a regular T-nut shape is insufficient to allow for y-axis rotation. Therefore, it is important to create curves on the surfaces to enable slight rotation. The question arises, how much curvatures would be the better choice? The curvature of the initial design is determined by the length of the bar and the positions of the belt, with a radius of 482.5 mm. I started by 3D printing a test with PLA to assess the stability of the dimensions and shapes. However, the carriage couldn't fit into the profile rail due to a lack of tolerance, sticking outside the rail. I aim for tight tolerance and smooth movements within the rail, so I adjusted the curved surface offsets to -0.05 mm, then -0.1 mm on both surfaces. Even with these adjustments, the ability to rotate in the y-axis with these large radius curves must be clarified. To achieve a wider rotation angles, I gradually decreased the radius and tested the carriages on the rail. I found that after the radius reached 200 mm, there was a more obvious movement when pulling and pushing the carriage. The 100 mm and 80 mm versions showed even more noticeable rotation, while they all slid nicely into the rail when moved, making the screws on the carriage produce different results. The 200 mm version was the easiest to slide, while the 100 mm and 80 mm versions tended to stick due to the turn of the carriage. This indicates that rotation is not the only factors to consider. The smooth slide of the carriage is also important. Considering both y-axis rotations and z-axis linear movement, the 200 radius version is likely the better choice. Currently, the carriages are 3D printed using PLA materials to ensure dimensional accuracy. However, this material is not ideal for parts that must slide smoothly. For instance, this became apparent with previous planetary gear set, where some teeth had flaws, and the rotations was not smooth after printing. I use this set frequently and have observed the extent of wear on the flaw teeth. As you can see, the set now rotates smoothly with minimum resistance. I disassembled the gear sets and noticed particles on the planetary carriage parts. This proves that PLA is unsuitable for moving parts, especially when used as a carriage in rail. I explore using Eagle's I-180 material, which is wear resistant and can make smooth contact with the surface hardened aluminum profile. I also inquire about using the roll profile without surface processing, and an engineer from Eagles confirmed that it should also work. After running some tests with different radii using the carriage, I found the results almost identical to the PLA versions. Many thanks to Eagles for providing a roll-off filament, which enabled me to continue this project. When printing, the material behaves more like ABS with some shrinkage and requires careful handling. It allows long-term direct contact sliding with the profile without needing lubricant, and can withstand temperature up to 100 degrees Celsius in the printer heated chamber. This material is suitable for building a lightweight compact door floating bar carriage. With these tests, I determined the most suitable radius based on the smoothness and rotations to prevent the floating bar from getting stuck at a certain angle while moving. As always, moving forward.